work some problems on beams, trusses, as well as plane frames. So, first problem. By both methods, by Castigiano's theorem as well as dummy load method or unit load method. One problem on cantilever, another let us take on simply supported beam. A general loading I will give W, E, P. Yes. Fine. That's maximum deflections. And slope also you can do it on similar level. Third problem. I take A constant because they are all fluctual members. Here it is actually loaded member, so A is constant or some value remain if it can vary this problem by varying this. Fine. Let's see. Horizontal displacement here. Here it is vertical. Here only vertical deflection I have. You can have slope also, you can take it, rotation. Then another two problems on frames, you can take it. horizontal displacement at D. So you can work all these 6 problems by Castigiano's theorem as well as unit load method. So let us take up first problem by Castigiano's theorem. So I will give you the equation Castigiano's second theorem. You have to apply for finding displacements. That's what I have told. The Castigiano's second theorem, the equation for flexural members, it is m x dmx delta mx by delta q dx divided by ei. This is your displacement at any point, displacement at any point j. You have to apply a load at that particular point j. So or that coordinate or point. Along that coordinate you have to apply a load qj, and where you have to determine the displacement. So if it is vertical deflection, you apply a vertical force. If it is a slope rotation to be determined, you have to apply a moment as the load. It is an imaginary type of load. So that value you can put it afterwards 0. If there is no load given in the problem along that coordinate. If there is a load, as it is in this problem, I have asked to find YB. There is a load already 10 kilonewtons, but you call that load as Q to start with some dummy load or fictitious load Q. Right? That's what I have told. Virtual load you have to apply and find the strain energy or moment at any point. And taking that Q also into account, then differentiate partially with that moment with respect to that load applied. So if you want to find slope, then you have to apply a moment as the load. Q is the moment applied. Right? You have to apply a moment and find the moment at various sections due to that moment also m, which is the fictitious moment. Ultimately you can put that moment value as 0. Here they ask you to find slope at P, you apply Q moment and take the moment at various sections, get this mx delta mx delta by delta q. Then after evaluating the displacement, it may be either yj, vertical displacement, or it may be theta, both. I am using the general notation as delta, which corresponds to either vertical deflection or it may be slope, both. Delta means need not be exactly vertical. Similarly, this qj force, it need not be vertical force, it can be moment. You have to differentiate that moment equation by that qj. So this is the formula we are using for Castigiano's theorem. And for unit load method on similar lines. So displacement at any coordinate delta j is given by this mx, small mx. Instead of this delta mx by delta qj, you have small mx. That's all the change, divided by dl. This formula is for beams and frames. Beams and frames, that is flexural members. This is the formula which we derived for finding the displacement in the previous class. For trusses, we have to use that delta j as sigma of p q, that actual force pi qi, right, qi delta pi, pi delta pi by delta qi or qj at any point. Delta pi by delta qj li divided by ai. So there also, wherever you want to determine the displacement, you have to apply a load, 50 shears load Q. It may be moment or it may be not moment, it is only force only, not moment. So there I have used the symbol F, I think. You can take it as Q because it is 50 shears. If that load is already there, that load value finally you can substitute. And this is the formula for dummy load method. This is by Castigiano method. This is for trusses. This is for beams and frames. For trusses, you can use this formula, and delta J is equal to sigma of pi qi Li divided by E. So this is by dummy load method, where this QI is the force in all the truss members due to application of unit load. This is due to unit load, not dummy load Q, it is unit load. Instead of Q, dummy load, you will apply unit load. So these formula you can remember for truss structure and beam and frame structure. And you can proceed that. This I have already derived in the previous class. Now we will take up that first problem by Castigiano's theorem. I will do it. So we have from Castigiano's second theorem, displacement at B. We have to find YB in this problem. So YB is equal to sigma of, because it's a beam fractional member, I have to use this formula. YB is equal to this mx, delta mx by delta qb. Instead of j, it is the point B directly. The Q load you have to apply at the point B. Delta qb is divided by L. This is what you have from that. So the same notation is the qj, j point, I am using straight away the point under consideration. Instead of delta, I am using straight away vertical deflection. If it is theta, I should use a moment there, that's all. So where QB is a load, virtual load is the virtual load applied at B. So like this. Q, B, A, C. Another load is there that you can take it as it is. That Q, 10 load, I am not taking that. Instead of 10, I am taking it as Q. But I substitute the value for Q. Instead of 0, I will take that 10 value. That's all afterwards. So this is 3 meters, 2 EI. Now, I have to find out moment at various sections all along the beam in order to find the moment. First, I will take a section x1. I will measure the distance from x from right end. Then, this moment about this section is valid from x is equal to 0 to x is equal to 3. That's at point C. The moment the point C is crossed, this load will come into picture. Naturally, the moment mx will change. I need another section. Like that. And that moment about that section holds good between x is equal to 3 to x is equal to 6. Or if you take it from this side, x equals 0 to 3. Either way, you can take that distance either from right to left or left to right. Here for x2, I will take the distance x from here. Both I am working. So if at all I want to take this, first I have to find the reactions here. So reaction here, it is total load only. That is nothing but 20 plus Q. And here moment is Q into 6. This 20 into 3. That is 60 plus 6Q. 6Q plus 60. So that is the applied moment clockwise. Resisting here should be anti-clockwise. So these are the reactions that we can find out. And these are the two sections we need for finding mx to cover the entire length of the beam. Now we can prepare the table. So QB is the actual load applied at beam. Then you prepare a table mx, or I will take segment BC and another segment AC. Two portions of the beam I am considering for mx determination. So here integration limit for BC, x is equal to 0 to x is equal to 3. Here x equals 0 to x equals 3. Both integration limits are same. And origin. So for measuring this limit or distance, here it is B, here it is A, is the origin. Or you can interchange it, origin, then limit. Then I will find out the moment mx. Here mx1. So what is the moment? It is just q into x. Yes, it is hogging. Hogging means because it gives a moment like this. As per our notation, this moment here on either side it is negative. This moment is positive as per our notation. So here this will be minus qx. For this, it is 20 plus q into x. It is clockwise, that is this positive 20 plus q into x. And this, that is negative, minus 6 into q plus 10. That's moment. mx. In this equation, mx for that entire beam, which consists of two segments to cover the integration limit, I have to work out mx. Then you find out delta mx by delta q. That's what I need. Then I will integrate it, add it, I will get stationary deflection. This is the procedure we follow in this Castigiano's method. It is just problem of finding moment at different section. This is similar to the drawing the bending moment diagram. There also to draw the bending moment diagram, you will take a number of sections, same kind of thing. Mx at various points, only delta mx by delta q, partial derivative. Here it is minus x. Here this is 0 because it is constant, or not 0, minus 6. Here it is
x minus 6.
X minus 6. So therefore, yb is equal to, or substituting mx, delta mx by delta q here, and ei also you can take it because ei is not constant, it is varied here. For portion BC, ei is ei, for this it is 2ei. That also you can take it. So here yb equals, so this equation is taken into consideration with two segments. For the first segment BC, it is 1 over EI is EI itself, 1 over EI into integral 0 to 3 limit for that portion BC 0 to 3. Mx is minus qx into delta mx by delta q is minus x dx. It is now only question of integration, nothing other than that. This is first, right? Now this portion, because it is sigma, for all the segments added. Next plus this portion, that is 1 over EI. EI value is
2EI.
2EI. You have to take 1 over 2EI into integral. Again, limit is 0 to 3. This into this. So that is 20 plus q into x. This you have to multiply without any mistake. So here, this I will do it. It is 20x plus qx minus 6q minus 60. If you expand this is into x minus 6. So now I have to multiply these two. So x into 20x, it is 20x square. Then it is minus 6 into 20x, it is 120x. Then qx square plus qx square minus 6qx. Then minus 6qx. Correct?
Yes, sir.
This 6qx and this 6qx I will add it. It will be
12
minus 12qx. Correct?
Yes, sir.
12qx. Then this is minus 36q. Plus 36q. Then minus 60x plus 360. Just check this once into dx. This is that. We integrate it now. So this is equal to 1 over di. This is 2x square dx. That is q into integral x square dx. Q I will take it outside. Then here plus 1 over 2ei. Right here integral. I will take this 20 plus q into x square. I take this 20 plus q into integral x square dx. I have grouped it as 20x square, 2x square, x square. I will keep it. This will be 20 plus q. Then x terms I will take it. This. Correct?
Yes.
X term. And this also. X term plus x terms. This is 120 minus 120x minus 12qx. 12qx,
Yes, sir.
that is, this is minus 6qx, another minus 6qx, so that's 12qx. Okay. So that is integral, this is 12qx.
Only x term we can take, sir. Minus 180.
All minus
180 into integral of x into dx.
minus 120
Minus 120 minus 60 ಇದೆಯಲ್ಲ sir.
plus 12q, correct?
Yes, sir.
Then plus 60, correct?
Yes, sir.
Into integral 0 to 3 of
X.
x dx.
Yes, sir.
All x terms I took it. Then lastly plus 360 into integral dx is constant. That's all. So I have simplified, nothing other than that. Now you integrate it. So this is 1 over vi. Integral x by dx is x cubed by 3. If I put the limit, it is 3 cubed by 3, that is 9. 9 cubed. Then plus 1 over 2ei into this. It is x cubed by 3. 3 cubed by 3, that is 9. 9 into 20 plus cube, that is 180 plus 9 cube. Next, this, I will integrate this. It is x squared by 2. Integral of x dx is x squared by 2. That is 9 by 2. 4.5. 4.5 into minus 120.
540.
540.
40.
Yeah, okay. 540. Then this is also minus 12 into 4.5.
54.
54 cube. Then this is 60 into 9, that is 540.
So 60 into 4.5.
60 into
4.5.
4.5, yes.
270.
370.
270.
270.
70.
So that is this. Correct?
Yes.
Minus. All minus.
Yes, sir.
Then this integral dx is x. I will put the upper limit 3 into 360. Plus
1080.
1080. Right?
Yes.
Now you can put the value of q is equal to
10.
So here, because it is a 50 CS load, right? So here after integration, you can put that value q equals 0 if there is load. Here there is a load of 10 kilonewtons given in the problem. Here q is equal to 10 since there is a load at that particular point. Here q equals 10. Substitute that q equals 10 and simplify and calculate the value of yb. That's all. So that is equal to 1 over vi into 9 into 10, 90. Then plus 1 over 2ei into, this is 90 plus 180, that is 270. Then minus 540. Then this is
Minus
minus 540.
Minus 270.
Then this is plus 270 plus 1080.
So it is 0, sir.
This
Zero.
go
270, 270.
270 plus 270, 540 divided by 2.
So it is minus 270.
Minus 270.
0, sir.
This also 0. So you will get just
90 by 8.
check this once calculation, because plus or minus you check once.
All minus.
I think it is all right.
Yes, sir.
Right? So that is 90 by ei. So your deflection there, it is 90
90
by
by 8.
That's all the problem. Now we will take up by unit load method, the same problem. Right? I have solved by Castigiano's theorem. That's all the procedure. Wherever you want to find the deflection, the displacement, at that point apply a load Q.
So if we ask at C, we have to replace 20
If
kilonewtons.
at C, if by C is asked in the problem, then apply Q at that C point. Instead of 20, Q will be there, and here, and that 10 you retain as it is, so you alter that moment. That due to the 10 you take it, due to Q you take it as it is. Ultimately, here after integration, put the Q as 20 there. If there is no load given here, if 10 is not there, then here you have to put Q is equal to 0. If only 20 is given in the problem, say, without that 10 kilonewton, then here you put that Q is 0 and that's all. And if slope is as, instead of vertical deflection, you have to apply a moment load, Q. Q will be moment. You have to apply Q like that. Then you have to return this 20 and 10 as it is, and also moment Q also you have to take it into consideration for finding the reaction as well as Mx. That's all the change. No, that
Finally, what is the value of Q we have to take? So when we are
Q value finally is 0.
0
After integration.
for slope.
Slope you will get automatically. Theta b will be there. Instead of yb you will get theta b. The moment will be in terms of Q.
Q
So that Q value you put it as 0.
0.
Because there is a moment load applied, fictitious load. It is not virtual load it is not regular load.
So if they give couple at point B value,
What?
say for a value of 20,
Yeah, that is load applied
Load
to
applied.
where the deformation is required. Here deformation YB is required, vertical deflection. I am applying a load Q vertically. If slope is as it is a rotation,
They
so
will-
rotation means I have to apply a moment load, not vertical load. Vertical load will not give moment. Slope, it is only vertical deflection.
Yes,
So I have to apply a moment load.
sir, instead of at point B, if they give 20 kilonewton meter as a moment,
Where 20 kilonewton?
if they give 20 kilonewton moment couple at B,
Okay.
then we have to replace that couple by Q, or we have to take
No. If where deflection is required or where deformation is required, there only you have to apply Q.
No, sir, I am talking about slope. If
Huh.
we compute slope, we have to apply moment M.
Moment load. Load you have to
Load.
apply fictitious load.
Fictitious
And that fictitious load is moment load.
Moment. If they give moment at point B,
At point
B,
C. If they give a moment
Moment.
at C, if they ask you to find the slope
Slope.
also at C, then you apply a fictitious load Q, and here as you did for vertical load, you put that Q value whatever that moment is given. If a load is already given in the real beam, in the direction where the deformation is required, that load you replace it by Q, and that value you substitute at the end. If there is no load is there at that particular point where deflection deformation is required, that load you put it as 0. That you have to be very careful.
for deformation, we have to replace by Q
So for deformation only,
only.
if deformation is slow, you have to apply a fictitious moment load Q.
That is always 0, finally.
And you have to put it as 0.
Zero.
There is no moment at that point given.
Given. If they give the moment,
If a moment is given at that point, you put that value.
that
as Q.
moment.
Why that confusion?
Yes, sir.
So it is not here also. I applied a load Q instead of 10, and the Q value I substituted as
Yes, sir.
10.
Yes, sir.
If the moment is also given there,
Yes, sir.
and if they ask slope,
Yes,
you
sir.
are applying a virtual moment, and that moment value only you will
Yes, sir.
substitute.
Yes, sir.
If here in this problem it has slope, here there is no moment.
Yes, sir.
So, but you are applying a virtual moment,
Moment for computation
moment
slope.
load Q for computation of theta b.
Yes, sir.
You will get in terms of Q. Then Q value you put it as 0.
0. Yes, sir.
That's all the thing. No other. You don't have any confusion.
Yes.
You apply always a load along that coordinate.
Yes.
That load either it may be a vertical load if deflection is required, or it may be a moment if slope is high. That's all. Now, unit load.